welcome to Girls Who Maths. So I'm Libby and you'll meet Alex later in another set of videos. We're going to go through some past papers, common topics, all kinds of maths related things on this channel. And today we're going to go through the AQA GCSE higher maths paper from 2019, and that's paper 1. In the next set of videos Alex will go through paper 2 from the same year. All of the videos for this exam paper will be broken down step by step in how we would solve the questions. There are different ways to solve them, so just let us know down below if you've done it a different way. Some of it might be oversimplified and that's fine. You can just skip to the bit where you get stuck or watch along and try and work it out with us. The videos will be broken up into questions just so you can easily find the question that you're looking for. Okay, let's get started. Start with question 1. So question 1 gives us two right angle triangles and asks us to calculate the value of y. Now, right angle triangles will follow the rule of SOHCAHTOA. So let's write that out. So I remember it as silly old Harry caught a herring trolling off Afghanistan. So now we want to figure out which sine, cos or tan fits for this triangle. So we label the small one first. This is the one we have the most information about. So the hypotenuse is going to be that longest side. The side opposite the angle we know is the opposite, and adjacent to that is the adjacent. Again, let's do the same on this one. Hypotenuse, opposite and adjacent. So looking at this one, we know the opposite and the adjacent, which means tan is the rule we want here. So tan of the angle, in this case the angle is labelled as x, equals the opposite, which is 6, over the adjacent, which is 10. Let's do the same for the bigger triangle. So we have tan of x equals the opposite, which we don't know, that's y, over the adjacent, which is 15. Now, you might have noticed we've got tan x and tan x, which means we can put them equal to each other. So let's form our equation. 6 over 10 equals y over 15. Now we have that equation, we can solve for y. So let's try and simplify this a little bit. 6 over 10, well, that equals 3 over 5. Again, equaling that to y over 15. Let's move the 15 across. We end up with 15 over 3 equals y. Right, now the best way I like to do this is we can divide by 5 and times by 3. So 15 divided by 5, well, that's 3. We times that by the 3 and we end up with 9. So that gives us y equals 9. Now remember, this one's a multiple choice, so all we need to do is check that this one is a value available to us, which it is, 9. So we circle that, and that's question 1 done. Let's start with question 2. So question 2 wants us to work out the value of 1 2/3 squared. Now this is a mixed number, so the best way to start these kinds of questions is to simplify it by putting it into an improper fraction. So because 3/3 make up 1, we can add the 3 onto the top to give our improper fraction, which would be 5/3. And remember, we want to square that, which also means we basically want to times it by itself. So to times fractions, you times the top 2 together and the bottom 2 together. That's going to give us 5 times 5, 25, 3 times 3, 9. So we're looking for something over 9. Now, the answer is in a mixed number, so we want to get our improper fraction back into a mixed number. And we do that by looking at how many 9s are going to go into that top number. So, 9 times 2 is 18. Can we go any higher? 9 times 3, that's 27. So that wouldn't be too many. So it's going to be a 2. It's going to be 2 and it's going to be over 9. So 9 times 2 is 18. We just need the difference between 25 and 18 for the remainder that goes on top of our fraction. So 25 minus 18 is 7. And there's our answer. So now we go back over to our multiple choice and see if the answer's there, which it is. We give that a circle, and that's question 2. Okay. Question 3 now. So question 3 wants us to work out the arc length in meters of a semicircle with a radius of 6 meters. So what does that mean? Well, semicircle, half circle. So it's going to look something like this. And radius, remember, is half of the diameter. So it's going to be that is 6 meters. Now, imagine it was a whole circle. If we wanted to work out the arc length, which for a whole circle is the circumference, that's the the length that would be all the way around the edge. If it was a full circle, we just work it out as 6d, with d being diameter, which also equals 2 of the radius. Now, we don't have a circle in this case, we have a semicircle, which is half of a circle. So if we did it for the full circle, this would be the answer. But because we're doing it for half the circle, we do the same as before, but we divide it by 2 to account for that half, and that's going to equal the arc length. Now, you might have spotted we've got a 2 on the top and a 2 on the bottom, so we can cancel them, which means the arc length is only pi r for a semicircle. That is quite a common thing. You might want to memorise that, it will make it quicker for you. So arc length for a semicircle is just pi r. R in this case is 6, therefore 6 pi. Go over to our multiple choice, 6 pi is there, circle it. Question 3. Okay, let's look at question 4. Question 4 says circle a fraction that's equivalent to 4.625, and here's our options. Now, anything divided by a quarter is either going to end in 0.25, 0.75, 0.5. That doesn't end in any of them, so it's not going to be something that's divided by 4. And that leaves us these two options. So, the best thing to do in this case is just to work it out like a normal division. 8 and 39, so we've got 39 divided by 8. Now, what is the answer? So, 8 into 3, none. 8 into 39, well, 4 times 8 is 32, so we'll put the 4 on the top, but that leaves a remainder. So 39 minus 32 is 7. We get a remainder here. Now, 8 into 70, this one takes a little bit more thinking about. 7 8s are 56, 8 8s 64, so it's going to be 64. So it's 8 8s. And 64 into 70, that gives us a remainder of 4, so we move the 4 over. But if you've noticed, we're already not in this decimal, so it's not that one. Which means, by default we have one left, but let's just sanity check and work this one out as well. 8 into 37. Again, 0 going to 3, but 4 going to 32, and that leaves a remainder of 5. 8 into 50, 6 8 are 48, so let's put 6 there, and that's 48, so the remainder here is 2. 8 into 20, well, 2 8s are 16, so let's put that there. The remainder between 16 and 20 is a 4. 8 into 40, well, 40 is divisible by 8, and it gives us a 5, which is our answer. Therefore, the answer is 37 over 8. Okay, question 5 is split into a couple of subparts, and this is the last of our easy 1 markers. So 5a is write 0.0009 in standard form. So standard form, remember, it's times 10 to the power of something. The number in front of the multiple must be a whole number. It must be somewhere between 1 and 9. It shouldn't be over 10. So, in our case, our whole number is going to be 9. And now we just need to work out what the power is. So, the easiest way I have to do this is to imagine that 9 was in the whole number position. How many moves would you have to make to get it into this? You would have to move 1, 2, 3, and 4. You'd have to move 4. And because you're moving backwards, you put a minus there. That's your answer in standard form. Question 5b now says work out 3 times 10 to the 5 over 4 times 10 to the 3. And it wants our answer as a normal number. So 5a was kind of an introduction, it introduced us into standard form. And now we have a division with standard form. So divisions with standard forms are quite easy. You can split them up. We can split them up into 3 divided by 4 and 10 to the 5 divided by 10 to the 3. So 3 over 4, that's 0.75. 10 divided by 10 to the 5 divided by 10 to the 3. When you have powers divided by each other, you simply just need to subtract them. So 5 minus 3, that's 10 to the 2. So what we end up with is 0.75 times 10 to the 2. Now remember, we want our answer as a normal number. And as I explained in 5A, the easiest way I find with standard form is to just count. So we're going +2, so we're going forwards 2. So we go forwards 1, the 7 would be in the whole number position. We go forwards again, it's in the tens. So that's 75. Okay, question 6. This is a 2-marker on probability. Anna plays a game with an ordinary fair dice. So remember fair, if it's a dice it means that the probabilities are equal, it's not biased, which means in this case on a dice there's 6 faces, so there's an equal probability of rolling all 6. That's going to be important. Okay, she rolls a 1, she wins. 2 or 3 loses, and a 4, 5 or 6 she rolls again, and in that roll again, if she rolls an odd number she's going to win, an even number she's going to lose. The question for 6A is to complete the tree diagram with the 4 missing probabilities. So the tree diagram I've drawn out here. So it's given us the probability of rolling a 4, 5 or a 6. We need to fill in the roll, first roll of a 1, a 2 or a 3, and then the second roll being an odd or an even. So, probability she rolls 1. As I mentioned earlier, this is a fair dice, it's not biased, so there's an equal probability of rolling any number on that dice. There's 6 numbers on that dice, so the probability of rolling one of those numbers is 1 of the 6. There's no bias, it's a fair dice. Now, for 2 or 3, that gives us 2 or 3. So remember the word or is important in probabilities. If we roll a 2 or a 3, the probability of rolling a 2 and the probability of rolling a 3 are the same, but because of that word or, it's an addition, which is 2/6, also simplifies to 1/3. Probability is 1/3. Now we have an odd and an even. Half the numbers on a dice are odd and half the numbers on the dice are even. Fair dice means that there's equal probability of getting any of them, and since half are odd, half are even, that's the probabilities. 6B now is as an extension on 6A. I've left a tree diagram here from 6A because that might help us. And the question is Anna more likely to win or lose? And you must being in bold, work out the probability that she wins. This is a 4 marker, so it's going to be a bit more in-depth. It's going to want a bit more work in and probably an explanation, a written part of the answer. Okay, the first thing we're going to do is we are going to work out the probability that she wins. And to do that, we're going to look at our tree diagram for the ways in which she can win. So if you remember from 6A, she can win if she rolls a 1. So I'm just going to make a note that that's a win. She loses if she rolls a 2 or a 3, so I'm not interested in that. But if she rolls a 4, 5 or a 6 and then an odd, she's going to win. So the probability that she rolls a 1 is important because that's a win. And the probability that she rolls a 4, 5 or a 6 and, I'm going to write and there because that's important, and the probability that she rolls an odd. So, probability that she rolls a 1, easy, we've already got that written down, that's 1 over 6. The probability that she rolls a 4, 5 or 6, half. Now remember, just worth noting here, if you didn't get these probabilities correct in the first one, still follow through with the ones that you've got and still work out the answer for this one. Or if you're not sure, put in some random probabilities and try and attempt this question because you will get carried over marks even if your probabilities aren't right, but you've worked it out in the right way. Okay, so we've just done the probability of 4, 5 or 6. And now the probability of an odd, that's a half. Remember what I said earlier, and and odd are really important in probability. So the probability of an and is a times, because that one has to happen and that has to happen for it to win. So you times a half and a half, we times the top and the bottom to get a quarter. Now, the probability that she wins is that she rolls a 1 first time, that's fine, or she can go via this path and roll a 4, 5 and 6 not odd. So it's a probability she rolls a 1 or this probability. So it's probability of a 1 or this one. Oops, probability of odd. So the probability of a 1 and the probability of this happening is a quarter. And remember what I said, or is an add, so we're adding these two together. That can be kind of complicated because we have different denominators. The best way to do that is to get them into the same denominator. Now, they're both go into 12. 6 goes into 12 2 times, 4 goes into 12 3 times. So we add those two together, 5 over 12. Now, the probability that she loses, we can work out in the same way. But we know that the probability she loses will be the opposite of that. Because she can either win or lose, there's no in between. The probability she loses is 1 minus 5 over 12. So it's the opposite, which is 7 over 12. We could work that out, and you can show this for explanation if you want. The probability she loses is 1/3. So it also equals to 1/3, or she could lose this way, a half. Oops, sorry, that was a mistake. That should have been a plus. Or she goes by the even route. So you end up with 1/3. Oh, again, that's an add. Add a half times a half, a quarter. Again, these both go into 12. So a third goes into 12 4 times, and a quarter goes into 12 3 times. So that's 7 over 12, which is what we worked out here. So that's just showing that we are correct. Now, is she more likely to win? That's the question, so we need to show that in our answer. If the probability she wins, we'll write that here, probability of a win is 5/12, sorry, and the probability of a lose is 7/12. The probability of a loss is greater than the probability of a win, and that's because it's 7 over 12 is greater than 5 over 12. And there's your 4 marking points. You're going to get 1 point for working out that probability. You're going to get another point for showing the calculations, and a point for showing the odds. And then that statement, that comprehensive, that you understand that she is more likely to lose, is going to get the answer. And you can write a sentence afterwards that's Anna is more likely to lose because the probability of losing is higher than the probability of winning. Something like that, and that'll secure you that 4th and final mark. Question 7 now. It's quite a wordy question for 2 marks. It's 3 friends arrive at a party, and their arrival increases the number of people at the party by 20%. In total, how many people are now at the party? These questions can be quite intimidating, there's a lot of words, but we just need to decipher which information we need. So, 3 friends, that's going to be important. Increase the number of people that are at the party by 20%, and that means that those 3 friends must be equal to 20% of the people already at the party. Okay, so let's simplify this into a bit of an equation that we can solve. Let's call the people that are already at the party X. So that is the people that were there before the friends showed up. So they equal 20%, let's write that as a decimal, 0.2, of the people that were already there, X. So can we work this out? Well, we can move that across. So it looks like that. Now that, just some people might be quite intimidating, but let's figure out an easier way to write this. So 0.2 is 2/10. And when you divide by a fraction, you can flip it upside down and make it times by instead. So we're dividing by 2 over 10, but we can write that as times in by 10 over 2. And all we need to do now is times the top and then divide. So we times by 10, that gives us 30, divide by 2, 15. So the number of people already at the party, X, is 15. The question though wants to know how many people were now at the party. So now at the party is the number of people that were already there, 15, plus the number of people that have just arrived, 3. 18. So there's 18 people now at the party. Question 8 now, so that's looking at division and multiplication of powers. So work out the value of 3 to the 12 divided by 3 to the 5, and that is all divided by 3 to the 2 times 3. Now, you'll see I've added a little 1, so when we have a number by itself, really there's a power of 1 there, but we just don't write that in standard maths. So that's going to be important, so just remember there is that 1 there. Okay, now by the rules of BODMAS, we work out what's inside the brackets first. So let's do that for the first bracket. 3 to the 12, and 3 to the 5. Now, I mentioned this earlier in the standard form question, but when we divide powers, we simply need to subtract them. And that makes it a lot easier. 12 minus 5, 7. Do the same for the second bracket. But this time, we have a multiplication. So multiplication is the opposite to divide. So we do the opposite. We add to the powers. So we do 3 to the power 2 plus the 1. 3 to the 3. Now, we've done the first one and the second one, so we just need to do the divide in the middle. Okay, so we've got a 7 and a 3, we've got a divide. We subtract. Okay, now that's your answer, 3 to the 4. What I would do is I'll work that out into a standard number. It doesn't say to leave it in this form, so for assurance you should work it out, but if you feel that you can't, you should just leave it in this form. But let's work it out. So it's 3 times 3 times 3 times 3, there's 4 of them. So let's work out each day. 3 times 3, that's 9. 9 times 3. I have a little trick for this. If you take your fingers, each one of the 9s, so we do 9 times 1, we count the remaining fingers, 9. 9 times 2, we have a 1, that's a 10. Remaining fingers, 8, so it's an 18. Third is what we want. We have 2 fingers, so it's a 2. And remaining, we have 7. 27. And then 27 times 3, a little bit more complicated, but it's 81. And the trick for that one is we could do, that would give us the same answer, which would be 9 times 9, which we know as 81. So if you, this one looks a little bit intimidating, we can do it that way and that'll give us the same answer, 81. We can do any multiplication in any order, doesn't matter. The answer is 81. Question 9 now gives us a drawing and it's a shaded semicircle inside a circle. The radius of the circle is 10, so that's been drawn on for us. And the diameter of the semicircle is 8, again, that's been drawn on for us. And it wants to know how many times bigger is the unshaded area than the shaded area. So this is 4 marks, you'll see there's a lot of lines on the paper, so it wants to show you workings. Okay, how do we start? Well, let's start by looking at the area of a circle. The equation for the area of the circle is something that you should memorise. Pi r squared, and remember that r stands for the radius, so we can work out straight away the area of the whole circle if it was all unshaded. So the area of the circle is pi times that radius squared, so 100 pi. Now some of you will know pi is 3.14, but because it's a non-calculator paper, it's okay to leave it as pi and have it kind of like an X or a Y. It's just a symbol that you carry through your calculations. It'll make it a lot more straightforward than timesing everything by 3.14 and trying to continue that decimal through. That will get awfully complicated. Okay, now let's look at this area of the shaded section. So a semicircle came up in an earlier question. Remember, it's just half a circle. So whatever we would do to work out the area of the full circle, we just need to half it to get the area of half the circle. So it's giving us a diameter here. We want the radius. So remember, that's half of the diameter. So the radius for this semicircle is 4. So the area of a full circle, if it was full, would be pi r squared, 4 being the radius, half of the diameter. But remember, we've only got half of that here. So dividing that by 2. So 4 squared, 16. 16 divided by 2, 8 pi. Okay, now I want to know the unshaded area compared to the shaded area. So the unshaded is going to be the area of the circle, 100 pi, but we need to take away the area that's shaded because we don't want that for the unshaded part. So that gives us 92 pi. How many times bigger? Okay. To work that out, we do a division. So we do the division of the unshaded over the shaded area. So that's 92 over 8 pi. Now, remember what I said about pi? It can be considered as a constant. So it's the same on the top and the bottom. We get rid 92 divided by 8. Now you've got to work out how many 8s go into 92. Let's think. See if we can do it as a mixed number. So we'll have a fraction here. 8 times 10, 80. 8 times 11 is 88. So let's put 11. The difference between 92 and 88 is 4. Now does that look a bit more straightforward? 4 over 8, half. 11 and a half, we can write that easily as decimal. 11.5. So the answer is it's 11.5 times bigger.